So in 1.8, we launched the first version of AI SQL Functions integration. And what this enables you to do is be able to invoke LLM completion calls directly within SQL. And the reason why you might want to do this is so that you can operate directly on results of your query with an LLM without having to kind of pull it down, call a completions API yourself, wire it all up, and so forth, which is especially useful when you have a large number of bulk data sets that you have to do a little bit of transformation in each and have to pipe them into an LLM. So like other things within Spicepod, you just configure a model that you would already do, and you can then invoke that model using SQL, which I'll show here in a second. So this is our cloud portal. We have a Spicepod deployed here in our team app, and this has got a bunch of data from just some of our daily syncs that we have. But the first thing I can do is just show you the AI function itself, and you just call it saying AI and select. And so if I just run that, essentially it's calling over to your model in the backend, which can be anyone from OpenAI, Anthropic, Bedrock, XAI. We can load and serve a model within the Spice runtime itself from Hugging Face, and we'll serve that. And so now I can say hello, and get an answer back from that. Now, previously, we had also added in a whole bunch of different search mechanisms. And so Spice supports both vector search, but also supports BM25 ranked full text search. And so here, what I'm doing is selecting from this data set where we have a bunch of wins, the answer, and then we're going to use a full text search over that data set, searching for the term search, and get results back. And there's like two results here, essentially. And if I want to vector search over that, we have a vector search UDTF, which is a table function, and I can do the same thing, and this will run vector search over that same data set, and now I have a result set of vector search results. And what you really want to do, though, is you want to combine different search modalities to be able to get the highest quality search results, because they will search for different things. For example, a vector search will be a similarity search, meaning that it will search for similar items. So if you search for, say, dog, it might return cat, or if you search for pet, it might return dog or cat. But a full text search is going to search specifically just on that matched keyword. And so you kind of want to get both and combine them together. And you can do that within Spice using this function RRF, and which stands for reciprocal rank fusion. And so you can combine here the vector search, which we're searching, the same function that we called above, the text search. We can give it a join key, which will improve the performance of it, and give it a time column to automatically give it a recency bias. So we're going to boost recent entries higher up the list in terms of the search results. And we can even rank or boost like each one of the different modalities higher as well. So we're actually saying give a higher weighting to text. We combine it all together and just give us one result set of search results. So here I can run this, and now I've got a re-ranked list of text search and vector search with recency bias, with boosting, all within one list within just a few lines of SQL code here. And so what I want to do once I've got this search result is I want to analyze the search result with AI, and I want to make that super easy. And normally what I would have to do is take each one of these results, manipulate it in some way, and then send it through an LLM to get an answer back, compile all that stuff, and get it back into where I want to use it. But with the AI function, essentially what we can do is take exactly the same query and now just add that AI function to the search. And what I'm going to do is say, analyze my prompt, the answer that I got back in one concise short sentence. I want to use GPT-4, and that's going to be my analysis of the search results that I have here. And so now I can run that, and it will take a little bit long because it's actually doing full LLM completions on this. And now you can see that I've able to apply that same analysis question with the answer all the way through to each one of the results without having to do a whole bunch of wire up of these services myself, and get that directly back into my application, which can serve in a dashboard or serve in the application to a user and so forth. And so imagine that you are wanting to do a whole bunch of analysis of a whole bunch of survey results. This gives you a really easy way to be able to do that and apply LM call to each in a consistent manner. Or imagine that you want to say, we work with a lot of companies, they work with different languages. Maybe you have a whole bunch of things coming in Spanish and you want to translate it. Then you could put something in here where you actually want to say, translate answer to Spanish in one concise short sentence, and you can kind of run that same thing. And this will give you a way to do, large scale translation across a whole bunch of data sets without having to wire up all the pieces in really just a few lines of SQL code, and to make it super easy for you. The final thing that I just want to show here is the explain plan for this search that we did. And this is kind of building off what Kevin showed you, is that this is doing large-scale vector search across a bunch of data that's in S3 vectors. And you can swap out that vector engine for different vector engines. So you can do that just purely in Spice, or you can use something like S3 vectors. And when you do use something like S3 vectors, as Kevin showed, we'll automatically do this partitioning across the indexes for you to make it very large and scalable. I'm gonna have to zoom out here so you can actually see, but if you come down to the explain pan, which shows you what actually happened beneath the hood, then you can come down here and you can see that in this case, Kevin showed 4, but I actually had it partitioned across 10 indices here, and essentially did a partitioning across all indices, searched across all of them, and then gathered all those results back together to give you that one results list that I showed you before. So in just a few lines of SQL here, you've got a very, very powerful way to query across federated data sources, search across them with different search modalities, re-rank them together, be very large scalable across multiple indexes, and then pipe that directly into some type of AI function to get additional analysis of that. Yep, and that is it. This is all available in 1.8 and 1.8.1.